Space, the final grand adventure. Final because it is unending. 14 billion years ago there was nothing, and then there was everything. All of the universe's energy was jammed into one dense point, which erupted with an inconceivable amount of force. This explosion created matter, and it was propelled out into every corner of the universe. This intense eruption is what we know as the Big Bang. At first, the universe was extremely hot, and the atoms and electrons in the newly born universe were unable to form together. But, as hours turned into weeks, and those weeks into years, we end up 380,000 years into the universe's lifespan, where the first hydrogen atoms formed. This allowed for the formation of the first stellar nurseries, and stars and galaxies were able to form. All of this leading up to now, 14 billion years later, where our galaxy, the Milky Way, has come together in the form of a galactic symphony for us to look up at and gaze to in wonder. Earth. It's the home of the human race. 6 million years ago, our ancestors began walking on two legs, and 300,000 years ago, humans in the form we are today appeared. 6,000 years ago, civilization began to form, and in 1609, a little over 400 years ago, Galileo Galilei invented the telescope. Some may consider this the birth of astronomy. However, civilizations ranging from the Romans and Greeks to the peoples of Africa and Australia have all looked up at the sky one time or another and left their mythos, their mark, on modern astronomy. Take the Milky Way for example, our very own galaxy. The name was in common use over 2,500 years ago in Western astronomy, but the usage is even older than that. So old in fact, its origins have been lost to time. There are of course many myths and legends surrounding the name. The Kaurna people of the Adelaide Plains of South Australia called the centre of the Milky Way Wadley Parry in the Kaurna language, meaning house river. It was believed that the river Torrens was a reflection of Wadley Parry. The earliest recorded mention of the Milky Way comes from the Greeks. They believe that the goddess Hera sprayed milk across the sky when feeding Zeus's infant child, who was born of a mortal woman. In Welsh mythology, many of the ancient oral traditions were derived from Celtic Britons, which were maintained by druids and bards until their recording in medieval Welsh literature. The Milky Way is associated with Gwydion Abdon, the son of the ancient mother goddess and sky goddess, and is named Caer Gwydion, which translates to the fortress of Gwydion. There are countless other names, myths and legends surrounding the Milky Way and the night sky as a whole. Many of these legends surround gods and goddesses, as well as being the reflections of rivers in many, many cultures. For now, we will cast our eyes back 400 years ago, just when Galileo pointed his new creation, the telescope, into the night sky. It's 1609 AD, and an Italian astronomer by the name Galileo Galilei just completed his first observations of the sky with his new invention, the telescope. His skyward target was the moon, and allowed him to figure out that the moon was indeed not flat and smooth, but in fact mountainous and rough. This was the first of many discoveries to come. He controversially discovered, for the time, that the planets of the solar system orbited the Sun and not the Earth, and that 4 stars orbited Jupiter. That last one may sound a bit odd, because that's not what he had discovered. He had in fact discovered the first moons orbiting another planet other than the Earth. He very quickly realised his error and corrected his mistake within days of the discovery. With the invention of the telescope, many mathematicians, physicists and curious individuals quickly got their hands on their very own telescopes and began their observations. Merely a year later in 1610, Nicolas Claude Fabry de Peiresc discovered the Orion Nebula, one of the brightest star-forming regions in the night sky. Nebulae are some of the most fascinating objects to look at in the night sky. Many are bright and big, and so are easy to see, much like the Orion Nebula. Others are small and dim and much harder to see, requiring the likes of the Hubble telescope to observe them. The Orion Nebula can be observed with the naked eye in areas with very little light pollution, and as the name suggests, it is located in the constellation of Orion, and forms the middle point of light of Orion's sword. Understandably, before detailed observations of that region of space were made with telescopes, the Orion Nebula was mistaken for just another star in the sky. The nebula lies around 1,300 light-years away and is 30 to 40 light-years in diameter. When de Peiresc first observed Orion, he referred to it as a cloudy nebulosity. It is a bright diffuse nebula, however there are many other types. On the smaller scale are planetary nebulas. They are formed when stars, much like our Sun, comes towards the end of its life. Once it has fused all the available hydrogen that it has been using for all its life, it will begin the fusing of helium atoms. In doing so, the Sun will begin to expand and cool down due to having a greatly increased surface area. It will also shed its outer layers, which forms a planetary nebula. When a star is dying, there are multiple different paths it can take which lead to very different outcomes in what comes next. Stars like our own will expand into a red giant to form a planetary nebula, and then become a very small and dense white dwarf. Stars much larger than our own will eventually become red supergiants and will then go supernova, an event so spectacular that they can be seen billions of light years away. The type of supernovae that can be seen at those distances are known as Type 1a supernova. They are extremely useful due to the fact that they have a very consistent brightness, and so can be used as what is known as standard candles to measure distances right across the universe. Once a supernova eruption has occurred, one of two things can happen. Either a neutron star is formed, which is the collapsed core of a supergiant which ejects particles in a narrow beam focused from the star's magnetic poles. The other outcome is the formation of a black hole. Black holes are one of the frontiers of modern physics. They are on the limit of what we are able to understand. The gravitational pull of black holes is so intense it warps space-time around it, and if anything passes over its event horizon, nothing, not even light, is able to escape. Due to this, you can never see a black hole. However, you can see its effect on the surrounding space. The glowing disk you see before you is called the accretion disk. It is an amalgamation of stellar debris and other matter caught up in the black hole's gravitational field. As the material swirls toward the black hole, it heats up and radiates energy. It is believed that the centre of each galaxy in the universe is a supermassive black hole. The first picture of a black hole was in April of 2017 and was of the supermassive black hole at the centre of M87, a galaxy over 55 million light years from the Earth. The image was taken by a global network of telescopes known as the Event Horizon Telescope. Much closer to home, in May of 2022, the first images of Sagittarius A star was revealed, the supermassive black hole at the centre of our galaxy. This image was once again taken by the Event Horizon Telescope. The global network is made up of many radio telescopes scattered across the planet, which allow observations to be made to an extremely high level of sensitivity and to a high angular resolution. Perhaps some of the grandest objects in the night sky are the very distant but very large galaxies that play host to billions of stars and thousands of nebulae. In 1924, Edwin Hubble realised that Andromeda wasn't actually a nebula, but in fact a galaxy. He described it as one island universe, a rather fitting description since the space between galaxies is incredibly barren. Starting at our own home, however, the Milky Way galaxy is what is known as a barred spiral galaxy of the type SABBC. The spiral arms of galaxies are of great interest to astronomers and astrophysicists, as conventionally, they do not make sense and should have disappeared on most galaxies long ago when they formed. But they did not. Some ideas of why they have remained to this day include the idea of a rotating density wave propagating through the galactic disk. Another idea, known as the self-propagating star formation theory, suggests that the star formation results from the collapse of clouds triggered by supernovae. Each one of these supernovae triggers the formation of several stars, which eventually die. The spiral arms of galaxies are a result of these bright regions of star formation being swept out by galactic rotation. Another type of important galaxy in astronomy is the elliptical galaxy. They are classed from E0 to E7, where E0 galaxies appear circular, and they progressively become more stretched in appearance. This way of classifying these galaxies is based purely on our perceived orientation of that galaxy, since we cannot find the true orientation in space of one particular galaxy. They tend to be found in rich clusters of galaxies and contain old stars, hence their red-orange appearance. There is next to no star formation happening in these galaxies, since there is little interstellar gas or dust for the formation of nebulae and stars. There are other types of galaxies than just these two. However, it is these two classes that make up the majority of the large galaxies in the observable universe. Other types of galaxies include dwarfs, irregulars, peculiar, and lenticular galaxies. So far we have looked into the origins of the name of the Milky Way, the beginnings of observations with the telescope, looked into the hearts of nebulae where stars are born, as well as what happens to stars when they die. We have observed and explored the external structure of galaxies, and finally, before this journey comes to a close, we will take a closer look at the internal makeup of galaxies much more closely. When you look up at night, you of course know that most of the white dots you see in the sky are stars, which are hundreds as well as thousands of light years away, save for the odd aircraft, satellite or planet. But when you look at those stars much more closely, you start to realise they're not all the same. Take our Sun for example, the nearest star to us, which is a mere 150 million kilometres away, a footstep away on the cosmic scale. It is a G25 class star. It gives off a white-yellow colour, and when you look at the Sun through an absorption spectra, there are obvious indicators of neutral metallic atoms and ions. This varies across different classes of star, as does the surface temperature, which plays a key role in classifying stars. The Sun has a surface temperature of around 5,800 Kelvin. The main sequent class of stars range from O class, the hottest stars found, with surface temperatures ranging from 30,000 to 60,000 Kelvin. On the lower end of the spectrum is M class stars, with surface temperatures around 2,500 to 3,500 Kelvin. Much like how galaxies can form clusters, stars can also form clusters such as open clusters and globular clusters. Open clusters are a collection of newly formed stars which originated from the same gas cloud. They tend to be small in number, ranging from just 10 all the way up to a few thousand stars. An easy to see open cluster is the Pleiades in the constellation of Taurus, the cluster in which also has the name the Seven Sisters, due to a grouping of bright stars. The names of the sisters were Maya, Electra, Alcyone, Taygete, Asterope, Selene, and Merope, and have their origins in Greek mythology. The other type of cluster mentioned was the globular cluster. These are a gravitationally bound group of hundreds of thousands to millions of stars. These clusters are found outside the plane of the galaxy in a region known as the halo, and are formed from old stars. The clusters are symmetrically shaped, which possibly indicates star formation once took place in a large spherical volume. Moving on from stars, we will now take a closer look at nebulae, their classes, compositions, and the role they play in the formation of new stars. Previously in this show, we looked at the Orion Nebula, which is a diffuse nebula. Now, however, we will take a look at the emission nebula known as the Lagoon Nebula. It lies about 5,000 light years away in the constellation of Sagittarius and was discovered by Giovanni Hodiena. It is known as an emission nebula as it is made up of ionized gases, which in this case is mostly hydrogen. The photons emitted from nearby stars are incident on the hydrogen atom's electrons and cause it to become ionized. Light is then emitted from the hydrogen ion as it recombines with its lost electron. It is an active star-forming region and plays host to the open cluster NGC 6530. Reflection nebulae are another form of nebulae commonly found throughout the galaxy. We've in fact already seen one. The Pleiades cluster plays host to one such reflection nebula. When stellar dust lies to one side of a star, the light is scattered out to the star-to-cloud direction. At that point, the nebulae appear bluer than the instant starlight reflecting on it. NGC 2023, as well as the Witchhead Nebula, are other good examples of reflection nebula. The last two types of nebulae we will be taking a look at are known as planetary nebulae and supernova remnants. Planetary nebulas form when a star expands into a red giant and lose their outer layers due to gravity no longer being able to attract the outer layers. A famous planetary nebula is NGC 6302, known as the Butterfly Nebula. It is a bipolar planetary nebula in the constellation of Scorpius and is located approximately 3,800 light-years from Earth. The nebula is host to one of the hottest known stars in the galaxy, with a surface temperature over 200,000 Kelvin. It is hidden from view due to the nebula's dust clouds, but it shines brightly in ultraviolet wavelengths. The ultraviolet radiation emitted from the star is what makes this nebula glow. The Crab Nebula is the final nebula we'll be taking a look at, and it is what is known as a supernova remnant. The event that formed the Crab Nebula took place in 1054. It would have been so bright that it was comparable to the full moon, and 6 times brighter than Venus. It was also bright enough to be seen during the day for a whole month. At the heart of the Crab Nebula is a bright and energetic pulsar. It is one of the brightest radio sources in the night sky and can be seen across the electromagnetic spectrum, from radio waves all the way to gamma rays. We have now seen a wide range of cosmic structures, from stars and nebulae to the galaxies that bring them all together. One final structure we will take a look at is known as the cosmic web. It's a combination of galaxies, galaxy clusters, superclusters, and galactic walls. The web forms as the gravitational attraction of the universe's matter draws larger and larger objects together. This leads to filaments where there is a large concentration of galaxies with large voids in between. Where the concentrations intersect is where clusters and walls are formed. In the grand tapestry of the cosmos, the cosmic web weaves a breathtaking narrative of interconnectedness. As we gaze upon the celestial marvels from galaxies to clusters, we're reminded of the intricate threads that bind every cosmic entity together. Like a vast unseen network, the cosmic web links the cosmos in a harmonious dance of gravitational forces. In this cosmic ballet, galaxies are not isolated islands, but nodes in a vast, interconnected structure. It's a reminder that, despite the immense distances, the universe is a unified entity, a singular cosmic symphony. As we stand at the edge of the observable, we are humbled by the sheer wonder of the cosmic web, a testament to the beauty and order inherent in the fabric of our universe.